So this is the second part of activity 5.2. This activity will not be found in your textbook, but I did post a copy of this in an Adobe PDF in Canvas. So perhaps you want to print this document out and then you can work alongside the video. Again, this document can be found in Canvas. The first question says, okay, we have a manufacturer of lawnmowers and they use this function. Looks like where the average cost will be equal to 132 times the number of lawnmowers plus 75,250 divided by X, or the number of lawnmowers produced. Whereas, what is the domain? Well, looking at this function, it looks like X can take any value except 0, right? Because we can't have division by 0. So I'm thinking all real numbers with the exception of X equals 0. Right? So the domain is all real numbers except X equals 0. Then we're asked, what is the practical domain? Well, really, I guess, how many lawnmowers can you produce in a week? I'm just guessing here. I don't know, 1,000 lawnmowers a day. Maybe you're closed Sunday. There's really no wrong answer here, right? I mean, a wrong answer would be negative something, right? You're not going to produce negative lawnmowers. So I'm just going to say 6,000, maybe 0 to 6,000. So here's my practical domain, right? X is somewhere between 0 and 6,000, but X cannot actually equal 0 because that would give us a problem. Part B, what is the minimum number of lawnmowers that must be produced in order to set the price at $199, right? So how many of these do we have to sell to bring our average cost down to $199? So here's the equation we must solve, right? I put in 199 for C of X, and I have to solve for X. I think I'm going to solve this by graphing. So I think I'm going to graph y1 will be the right side of my equation, and y2 will be the left side of my equation, and the intersection should be my answer. So I press y equals, and just make sure you separate the numerator and the denominator with parentheses. Okay, but then we won't run into problems. So there's my numerator. And we need to divide this by X, right? And then Y2 is going to be the 199. And then we need a window. So again, remember we said our domain could be from 0 to 6,000. We'll see how good this looks. And I don't know, maybe we'll count by 600s. That will give me 10 tick marks. And then for Y min, we'll go from 0 to, what's a good Y maximum? How much does a lawnmower cost? I don't know, 500 bucks? 600 bucks? I'll put in 600. Just kind of spitballing here. And let's see what this graph looks like. That's not bad. Let's see if we get the intersection. And the intersection does appear on our viewing window, so this is pretty good. Okay. Now, you remember, to get the intersection, we press second, we press the trace key, because we're going to calculate the intersection, number 5. I press enter, there's my second curve, my guess, and it looks like 1,123. So I have to sell 1,123 of these lawnmowers to bring my average cost down to $199. Or I really have to produce and sell that many. So here's my answer in words, right? We must sell 1,123 lawnmowers to bring the average cost down to $199. And I might even going to squeeze in produce and sell. Okay. Question C, what's the horizontal asymptote of this function, and what's the practical meaning? So what I did was I took the leading coefficient. Remember, if our power on the numerator and the power on the denominator, right? The exponent, if they're the same, right? If we're of the same order, right? This is x to the 1 and x to the 1, right? The degree is the same on the numerator and the denominator. We could take the leading coefficients and divide them. So 132 and 1 are my leading coefficients, right? The number in front of the variable. So I get y equals 132. So the practical meaning here is my average cost will never fall below $132. No matter how many of these things I produce and sell, I can never bring my average cost below $132. Question D. What will the average cost be if only 300 lawnmowers are produced? So here's the equation I'd have to solve, right? I'd substitute 300 in everywhere I see x in my original equation, somewhere up here. So if I replace x with 300 and do the math, I'm left with $382. So if I only produce 300 lawnmowers, my average cost will be $382.83 per mower. All right, let's take a look at example 2. Right, we have the concentration of a drug in the bloodstream. It's measured in milligrams per liter, and here's the function. So it says how long after an injection will it take for the concentration to be 0.1 milligrams per liter, and then we're told solve this graphically. So this is the equation we'd have to solve graphically, and again I'm going to graph the right side and the left side of my equation. So my y1 will be this 14t divided by 3t squared plus 2.5, and y2 will be the 0.1. Right? I'm graphing essentially both sides of this equation. So let's take out our calculator. And again, we'll press y equals. We'll clear out what we had from the previous problem. Remember, y2 is going to be that 0.1, and y1 will be the 14t divided by the 3t squared plus 2.5. So we have something that looks like this. Okay, now our window, this is tricky. See, this y2 is going to give me a straight line at 0.1. So when I'm thinking about y minimum and y max, 0.1, well, if I go from, say, negative 0.5 to positive 0.5, remember, I'm going to have a straight line somewhere at 0.1. That's in between here, right? It's going to be really small, so it's going to be hard to see. So my scale, I'm going to count by 0.1 increments, or a tenth increment. And then for my x, I don't know, remember, we're talking about minutes, right? This is how many minutes it will take for this drug to leave your system. So I guess 60 minutes is an hour, 120 minutes is 2 hours, so maybe we'll try 150 minutes. And I'll count by, say, 15s. All right, just take off the last digit. I press graph. All right, there's my first curve. It's not too bad. Let's see, the 0.1 should happen right here, right? There's a straight line. All right, and we see the intersection. This is not too bad. All right, so now we need the intersection. So I press second, calc, number 5, the enter. And it looks like our intersection's at 46.64. So I guess how long does it take for our drug to get down to 0.1 milligrams per second? I'm sorry, milligrams per minute. Let me try that again. Milligrams per liter. Again, according to our calculator, it's going to take 46 minutes, or 46.6 minutes. So we can say it will take 46.6 minutes for the concentration to reach 0.1 milligrams per liter. We're then asked to find the concentration after 5 minutes. So the equation we'll need to solve will look like this. So let's get out our calculator. And if we look at the previous graph, if I press the trace key and I press 5, and first make sure that this y1 says 14x divided by 3x squared plus 2.5. If you don't have the correct equation up top, you can just press the up arrow and it will scroll between 0.1 and our equation. So we want this equation, right? The 14x divided by 3x squared and so on. Then press the trace key and press 5 for 5 minutes. Then press enter. And it's saying when x is 5, y is 0.90. And there's my answer, 0.903. Right? We could also do this the long way by doing 14 times 5 divided by 3 times 5 squared plus 2.5. We'll get the same answer. So a formal answer, the concentration will be 0.903 milligrams per liter after 5 minutes. Right? That's my concentration. Let's take a look at number 3. So we're told that a company, the average cost function for a particular company is given by this a of x equals 400 plus 2x divided by x. So we're asked, what is f of 30, and what's the practical meaning of f of 30? So f of 30, if we replace the x with 30 and we solve, we get 15.33. So we could graph this, or we could actually just type it the way we see it and press enter. See, we get 15.33. So the practical meaning, well, if 30 units are produced and sold, the average cost per unit will be $15.33. We're then asked, okay, well, what's the domain of this function? Again, we can use all real numbers. We just know that x can't be 0 on the bottom. So for domain, I'm going to say all real numbers except x equals 0. For the practical domain, well, we have to take a look at this again. It's tough to come up with a practical domain because we don't really know anything about this company or what are they producing. Are they producing, pianos or lawnmowers or cars? So anything you put is going to be okay. You just can't have a negative value, right? Because we're not going to produce a negative number of items. And, we're probably not going to produce 1 billion items. So, I'm just going to pick a number at random. I'll say 600. Right? So the practical domain could be anywhere from 0 to 600. So there's my practical domain. Part C says, what is the horizontal asymptote of this function? And what does it mean in the context of this problem? Well, I took the leading coefficient of the numerator and the denominator to get y equals 2, right? Here is the degree of my numerator is x to the 1. The degree of my denominator is x to the 1. So the coefficient, so there's 2 divided by 1 to get y equals 2 is my horizontal asymptote. And the practical meaning, well, the average cost will never equal or fall below 2. No matter how many units I produce and sell, I can't bring my average cost below 2. Next, we're asked to find the horizontal and vertical intercepts. And then we want to know, do the intercepts have a practical meaning? Well, if you remember, to find the vertical intercept, you plug in 0 for x and you solve for y. So if we put in 0 here, we have a problem. We can't have a division by 0, so there is no vertical intercept. So to find the horizontal intercept, we're going to substitute 0 for y and solve for x. We could either graph both sides of the equation, or we could actually cross-multiply. Right? If we cross-multiply, we'd have 0 equals 400 plus 2x, and then we would just solve. But I'll graph it. So here's me graphing the right side of the equation and the left side of the equation. My window, we said, will go from 0 to 600. Remember, we're looking for the straight line at y equals 0, so I'm going to just do a little bit below 0 and above 0. And here's my graph. And you notice we don't see an intersection, right? We want to know, when does this blue line cross the red line, and it doesn't. But if I expand my window, let's say I went to negative 600, look what happens. There actually is an intercept here. Okay? But this intercept doesn't really make any sense because this is negative, right? How many items would I have to sell for this thing to cross the x-axis? I'd have to sell some negative number. If we want to actually find this number, I can press second, calc 5, enter, enter, enter. Oops, I didn't move my cursor to the right side. Let me try that again. Second, calc number 5, and it says, okay, where's my first curve? So I press the left arrow a couple of times so I can see my curve. Right? So I'll press enter. My second curve will be the 0. I press enter. And my guess, I don't know, somewhere over here is what I'm looking for. And it says it happens at negative 200. By the way, it would have been much easier just to solve this by hand, by cross-multiplying. But anyway, we get x equals negative 200. And the intercept really has no practical meaning because you cannot produce negative 200 units. That completes this lesson.